So, hello students once again, and I've come back with the past paper numericals of the AS level Cambridge board exam, code 909701, and the topic is enthalpy changes. And this I'm going to do part 2. Part 1 I have already done, so you can check up my previous video to get some more questions on enthalpy changes. Now, going to start with this lecture. I'm going to explain you in thorough detail all the steps involved so that even if you are weak in chemistry and if you have not followed in your school, you will be able to follow most of the topics and the concepts involved in solving these numericals. So let's go ahead. So the first question that I have got is taken from the March 2017 paper, variant number 22. The question says that hydrogen chloride undergoes a reversible reaction with oxygen, and this is the reaction that you see: 4HCl gas plus O2 gas in a reversible reaction gives you 2Cl2 gas plus 2H2O gas. So the physical states of the substances have been given. They really do not matter much in solving the problem because the enthalpy change also is given for the same state. So nothing you have to worry about. But when you see the data, you find that you have got the enthalpy change of formation of HCl and H2O, that is HCl and H2O, but you find that oxygen and chlorine are missing. So what is the reason? Can you think about the reason why oxygen and chlorine are missing in the data? The answer to that question is that the enthalpy change of formation of the elements when they are in their standard states is taken to be zero by convention. So remember that. So these two values are zero, and that's why they are not given. And why they are zero? Because they are the elements and in their standard states. So you need to know only the enthalpy change of formation for water and for HCl. And you have to find out the enthalpy change of reaction. That means when the reaction takes place in this direction, what is the enthalpy change of reaction? That means how much heat is evolved or absorbed. So whenever you have to find out the enthalpy change of reaction and the enthalpy change of formation has been given, remember that for formula that enthalpy change of the reaction can be found out by the enthalpy change of formation of the products minus the enthalpy change of formation of the reactants. All right, so all these are standard values. So now for the products we will see only water, and the water value is minus 242, but it's for 1 mole. There are 2 moles, so it will be 2 times of minus 242 and then minus the reactant, that is HCl, but this is 4 times, so minus 4 times of minus 242, and that now becomes very easy. Minus and minus, minus and minus, obviously it becomes plus, and this is minus. So when you solve this, and I have written down the solution from the mark scheme, and see it is the same. 2 times minus 242 minus 4 times, sorry over here, not minus 242, sorry, minus 92, right? So let's make it minus 92. Yes, a silly mistake on my part, so don't worry. So now if you see this now, it's the same thing which you get over here, which is very easy to solve, and you get the answer as minus 116. So this answer here is minus 116 kilojoules per mole. The unit has already been given, so minus 116 kilojoule per mole is the answer, and that is the enthalpy change of reaction for this particular reaction. So I think you understood this. It was pretty easy. You have to only remember that the enthalpy change of formation for the elements is taken to be 0 by convention, and when the enthalpy of formations have been given and you have to find out the enthalpy change of reaction, you have to do the products minus reactants. Products here are two water molecules. So take this value, subtract the HCl, which is 4 times of minus 92, simple mathematical calculation, and you get minus 116 kilojoule per mole. That's the answer. So I think you understood this. Now we go on to the next question, which has been taken from the winter 2017, the paper number 22, the code 9701. Now it says that at 450 Kelvin, phosphorus 5 chloride, that is PCl5 gas, decomposes to form phosphorus 3 chloride, that is PCl3 gas, and chlorine gas. A dynamic equilibrium is established as shown. So you can see this here, that it is PCl5 gives you PCl3 plus Cl2, and the delta H value is already given. See, the delta H value. So remember that this delta H value is actually the enthalpy change of the reaction. That means when this reaction takes place, obviously in the forward direction, then so much heat plus 124 kilojoule per mole has been absorbed because of the plus sign. So this is the enthalpy change of this reaction. And now once again it's an element, so the enthalpy change of formation for this chlorine will obviously be 0, so don't bother about that. And because you have been given the enthalpy change of formation, and you have to find out for the reaction, so obviously you can write that enthalpy change of the reaction is equal to same thing, the enthalpy change of the formation of the products minus the enthalpy change of the formation of the reactants, and this value is already given, so this is 124, and products, that is PCl3, and this value is already given, minus 320 minus, and you have to find out the value for PCl5, so let it be x. So this will be minus x. So this x you have to find. So obviously this x will be minus 320 and minus 124, which is equal to minus 444 kilojoules per mole. So I think that is the answer, and I think I will show you the answer. So let's go and check the answer. Okay, so let's go and check the answer. Yes, it is the same, minus 444. So I think you understood this. You can just go over once again. So here the enthalpy change of the reaction was already given, and you had to find out the enthalpy change of formation, whereas in the previous question the enthalpy change of formation were given and you had to find out the enthalpy change of the reaction. So a little bit change in the format, but not so difficult to understand. Now we go to a third type of question in which we will come across many new things, many new concepts to understand. So let's see, this has been taken from the winter 2016, paper number 21. For many compounds, the enthalpy change of formation cannot be calculated directly. An indirect method based on enthalpy changes of combustion can be used. The enthalpy change of combustion can be found by a calorimetry experiment in which the heat energy given off during combustion is used to heat a known mass of water and the temperature change is recorded. Now the first question says, explain the meaning of the term standard enthalpy change of combustion. So you have to define it. It carries 3 marks. So the keywords are important. So combustion, obviously combustion means that the substance is being burnt, right? Substance is getting oxidized. So let's see what is the definition for the enthalpy change of combustion. So see this. This is how you are supposed to write. It is the enthalpy or the energy or the heat change when 1 mole of a substance. So the key word here is 1 mole of a substance. So don't forget to write 1 mole. So when 1 mole of a substance burns, right, combusts or reacts in excess of oxygen. So this excess word is important. Or you can say completely burns or reacts in oxygen. So 1 mark for this, 1 mark for this, but you have to also write under standard conditions. So if you write that, you get 3 marks. So I think you understood the meaning of this. So that's not difficult at all. So that is the first part that you did, the standard enthalpy change of combustion. Now what is the equation for the complete combustion of ethanol? Let's see that. So as you already understood that combustion means that it has to react with oxygen. So C2H5OH, right, and it undergoes a combustion, that means plus oxygen, right? So let's do that. 1 minute, let me connect it to the internet. Okay, so let's go forward. So think about it, what will happen during a combustion when ethanol undergoes combustion? What will happen? Remember that whenever such a compound undergoes combustion, then the carbon forms carbon dioxide. The hydrogens and the oxygens, they form water. So you must know that these are the products, carbon dioxide and water. Then later on try to balance. So first we try to balance the carbon. So carbon, that is 2. So we must write 2 over here so that the 2 carbons are balanced. Then let's see the hydrogens. We have got 5 and 1. That is 6 hydrogens. So we must write 3 over here. 3 2s are 6. So 6 hydrogens are balanced. Now let's see how many oxygens. 4. See this, 4 and 3. 7. So if you write 3 over here, 6 and 1, that is 7. So this equation is balanced. So I think you understood this. So let's see then what is the answer given. It will be the same obviously. So let's go and check it. Right? So let's see. So see, it is exactly the same which I wrote. So I think you understood this, how to do the balancing and how to write down the answer. Now let's go to the next part, and this is somewhere where I have to actually tell you many things, and it is that in an experiment to determine the enthalpy change of combustion of ethanol, 0.23 gram of ethanol was burned and the heat given off raised the temperature of water by 16.3 degrees. Calculate the heat energy change Q during the combustion of 0.23 gram of ethanol. Now here you know that the formula that we use is that the Q is equal to M, C and delta T, where M is the mass, C is the specific heat capacity and delta T is the change in the temperature. Now what should we take as the mass? And that is where most of the students go wrong. They think that the mass that they have to take is this 100 gram of water and also the 0.23 gram of ethanol, which is incorrect. Because ethanol is actually undergoing the combustion. It is burning, but it is raising the temperature of water by 16.3. So the mass that you have to take is the mass of the water whose temperature is rising, not the mass of the ethanol, which is simply undergoing combustion. So don't forget that. So here the mass that will take will be 100, and C, as you know, the specific heat capacity is 4.18 joules, right, per Kelvin, and then the delta T is already given, that is 16.3, right? So if you do that, then you are going to get the answer for Q, and it is going to be, see, 6813.4. If you don't want to write the 0.4, then even 6813 is also acceptable. If you want to write for 3 significant figures, then 6810 is also acceptable. If you want to write down for 2 significant figures, then even 6800 is acceptable. So we will prefer to write 6813.4. This is the correct answer. So if you multiply this, you get 68, yeah, so you get here 6813.4. this is the heat evolved, right? But this is the heat evolved from 20.023 gram of ethanol, remember that. But it's not for 1 mole, so we have to still do that part we still have to do. So let's go and see how we do that. So 1 mole of ethanol. Now what is 1 mole of ethanol? So here we are using the concept of mole. So for that you have to write down the formula, C2H5OH. That's the formula of ethanol. And then you can find out the MR, the molecular mass. And now taking the atomic masses from the periodic table, carbon you know is 12 into 2, that is 24. Hydrogen atomic mass is 1, so 5, plus oxygen mass is 16, and plus 1. If you do all that, you get 46. So 46 gram per mole, that is the molar mass of ethanol. So remember that this much of heat was given out from 0.23 gram. So if you do like a simple ratio proportion or the unitary method, then 0.23 gram actually gave you a heat equal to 6813.4. So 46 gram, that is 1 mole, is going to give you how much. That value you have to find. So obviously this will be equal to 46 into 6813.4 divided by 0.23. But obviously this is going to give you joules. This is going to give you joules. So if you want in kilojoules, then this will be further divided by 1000, right? And if you do that, then what is the answer that you get? I'll just show you. Yes. So you will get this answer, minus 1362.68. If you round it, then it will be minus 1362.7. If you further round it, it will be minus 1363. So they are accepting all the answers. So let's take the middle one. So let's take this minus 1362.7 kilojoules per mole. That is the answer. So I think you understood. The biggest mistake which the students do is that they don't understand what mass to take over here, and that mass is 100. This 0.23 is not to be taken because this ethanol is simply undergoing combustion. It is not, this is not where the temperature is rising. Temperature is rising only for 100 gram of water. So you have to take this mass, and then this is a specific heat capacity for water. This is the rise in temperature. This 0.23 gram will be used in the next step, where you have to find out the heat evolved for 1 mole of ethanol. That is the enthalpy change of combustion. So I think you understood this, because this is where most of the students go wrong. And now let's go to another very important question, in which we will construct an enthalpy cycle and show you the method. That is, the table gives some enthalpy changes of combustion values. So carbon enthalpy of, so see, this is one difference. Here you are getting the values for the enthalpy change of combustion, whereas if you remember in the previous questions, you were being given the enthalpy change of formation. So this type of question is to be done in a slightly different way, and you have to understand this very, very clearly in this method. So please be patient, patiently go through the method that I'm explaining, so that you don't make a mistake in your exam. You are very likely to make a mistake here, because you are used to solving the questions where enthalpy change of formation is given, but this is where the enthalpy change of combustion is given. So you have to find out the enthalpy change of formation now. You have to find out the formation. See, construct a labeled energy cycle to show how these values could be used to calculate the enthalpy change of formation. Not the, so they are asking for formation, right? So this is the formation of propanol. So whenever any substance is formed, we have to take the elements on the left hand side. That is the definition of enthalpy change of formation, that 1 mole of the compound is formed from its elements in their standard states. So the elements which make up propanol are carbon, hydrogen and oxygen. 3 carbons, total 7 and 1, 8 hydrogen, so 4H2, and there is only 1 oxygen, so half O2. So this will be the equation for the formation of propanol. But you have to use the combustion data. So see, if this undergoes combustion, carbon undergoes combustion, obviously it's going to form 3CO2. When 4H2 undergoes combustion, it's going to form 4H2O. No need to balance it. And when propanol undergoes combustion, it forms the same products, because it is a balanced equation. So it will give you the same product. So this is the way you have to construct the enthalpy cycle. But now let's make a Hess cycle for this and see how does it vary. So you can see here that this delta H1 is equal to delta HF and delta, which is definitely, I can call it as a reaction or a formation. Here I can say it is a formation. All right, so let's say this is the formation. So delta HF plus delta H2. See, delta H1 is equal to delta HF plus delta H2. So if you have to find out the delta HF, then it is delta H1 minus delta H2. See how it has changed. It's now become the reactants minus products, not the products minus reactants. So the very important thing to understand is that when enthalpy of combustion is given, it is the reactants minus products, and when an enthalpy change of formation is given, then it is products minus the reactants. So this is the key point that you must understand, otherwise you will go wrong. After that it becomes easy. 3 carbon means you multiply this value by 3, 4H2 means you multiply this value by 4, add these two, and this value is already given, and then simply you use the formula. I have multiplied this and added them together. I get this. So now after that I use a simple algebra where I do delta H1 minus delta H2. The 2 minus become plus, and then finally I get minus 302.7 kilojoules per mole, and that is the answer, minus 302.7 kilojoule per mole. So I think you understood this, and I have explained you in extreme details, explaining each and every point. If you have not understood, please go through the entire explanation once again until you are convinced and you can write down all the steps on your own. Thank you very much for watching, and if you like the lecture, please give your comments and recommend it to your friends and subscribe to the channel, because I'll keep posting new videos of the past paper solutions, particularly the problems, and later on organic chemistry. Thanks very much for watching.